Have you ever looked up at the night sky and seen a tiny, moving star? A spark of light gliding silently across the velvet darkness. That isn't a star at all. It's a satellite. A human-made moon on a mission. And like you, it has a brain. This isn't a brain of flesh and blood, silicon, gold. A computer designed to think in the most hostile place we know, the vacuum of space. These celestial minds are our eyes, our ears, our messengers in the cosmos. Their creation is a story of incredible care and ingenuity. These brains in the sky are essential navigators of the modern age. They guide our cars and ships with invisible threads of data. They watch over our planet, tracking the fury of hurricanes, the slow, silent melt of ancient glaciers. They connect us, weaving a web of communication that can instantly link a classroom in Kansas to a scientist in Antarctica. Without these tireless electronic thinkers, our world would be a far less connected place, less understood, less safe. Building them is not just an act of engineering. It is an act of foresight, a way of extending our senses beyond the thin blue line of our atmosphere. The story of a space brain begins not with a bang, but with a whisper of curiosity. It starts with a question. The journey begins in a place far from the stars, a simple conference room. Team gathers around a table. Engineers, scientists, programmers. They are the architects of this new mind. Whiteboards, pencils, endless conversation, sketching the satellite's purpose, breaking the mission into thousands of tiny tasks. Point a camera with pinpoint accuracy. Listen for faint radio signals from deep space. Every function is mapped, a blueprint for the computer's digital soul. Choosing physical parts from the blueprint. Packing a backpack for the hardest hike you can imagine. Lightweight, incredibly durable, ultra-low power. Selecting radiation-hardened chips. Energetic particles from the sun and galaxy. Those particles can scramble a normal computer's memory in an instant. But a space brain must shrug them off and keep thinking clearly. Every processor, every memory module is chosen for its proven resilience. Once the design is locked, the real construction begins. The satellite's brain is assembled in a clean room, a place cleaner than any hospital operating theater. Workers are covered from head to toe in special suits because a single speck of dust or a flake of skin could cause a short circuit and cripple the computer. Here, under intensely bright lights, skilled technicians work. Robotic arms and microscopic tools place each tiny component onto the circuit board. It is a painstaking process, like a watchmaker assembling the most complicated timepiece in the world, where every connection must be perfect. When the prototype is built, its ordeal truly begins. First, it is placed in a shake table. The machine violently rattles the computer, simulating the bone-jarring vibration of a rocket launch. Engineers watch nervously, monitoring every circuit. The brain must endure this mechanical fury without a single hiccup. If even one solder joint fails, it is sent back for strengthening and retesting. The final, tested brain is carefully integrated into the satellite's body, which is then sealed and transported to the launch site. Encased within the nose cone of a powerful rocket, it waits. Then comes the moment of truth, the launch. A controlled explosion of unimaginable power lifts the rocket off the pad, pushing the satellite faster and faster, tearing through the atmosphere. For the tiny computer inside, this is a period of silent endurance. Minutes later, high above the Earth, the ride smooths out. The satellite separates from the rocket, floating freely in the silent vacuum of low orbit. A signal, sent from a ground station hundreds of miles below, travels up to the satellite. It is a simple command. Wake up. In response, the satellite's brain flickers to life for the first time in its new home. It runs through its initial checklist, then orients its antenna and sends its first message home.